Hi, I'm Tony. I'm going to talk about the circuit design robot. And here's some introduction. So there are two circuits on the robot. The main circuit that controls the motor motion, and the kicker circuit, which controls the kicker of the robot. Do note that both of these circuits are still under developing. Especially this kicker circuit needs quite a bit of improvement. So our controlling unit is the Arduino Diamondback, which receives Wi-Fi signals and then decrypt the Wi-Fi signals into messages, and then according to each message, output different signals to the board. The power of the circuit is driven by a 12-volt Ni nickel metal hydrate battery. On rating, it can provide up to 18 amperes for about a minute and a half. It's rated 1,800 milliampere hours, so it's actually a pretty good battery. So on the main circuit, it takes unified 5-volt digital signals from the Arduino board, and it consists of one shift register, one hex inverter, and two H-bridge motor driver. And those are just the parts number that you guys can Google, or we'll look into the data sheet afterwards and kind of look at the pinouts. So the next page is a sample circuit of driving one motor. So as people can see, I'm using the first chip, which is the shift register, using two of the outputs to control one motor. The first output will be the directional output. When it's set to 1, the motor will spin one way, and when it's set to 0, it will spin the other way. And the second output will be a PWM fake analog output, which we use the program, Arduino program, to trigger an interrupt and rewrite the digital, rewrite the value of the shift register every so milliseconds. And therefore, when we turn on and off the shift register fast enough, it will actually appear to be at an analog voltage instead of a discrete 5 or 0. And the directional output actually gets passed into the inverter and gets the second directional output, which is always opposite of the original direction output. And these are the data sheets for each chip, starting from the shift register. Shift registers takes 3 inputs from the Arduino board. One is data in. The second one is the clock of how fast you want to turn, how fast your data is passing in. And the last one is the output, the latch pin, which is the clock for displaying the output of the shift registers. So basically, we're using this shift register to turn a serial output from an Arduino board into a parallel output that can control all the motors. Basically, a easy way to convert 3 pins on the Arduino into 8 pins, or potentially more. And then we have the the hex inverter, which is a very trivial IC component. It just inverts your signal. It just inverts your signal and gives out the opposite value of it. The motor driver here, we can see that it takes one enable input and 2 directions to output two output values. The enable pin is connected to the PWM signal will actually control how fast the motors run. And this is a small diagram of how the shift register, how the motor drivers are hooked up to the motors and the signals. And we utilize two of these chips and 3 of the drivers to drive 3 motors. And the last one, we are probably going to use it for the dribbler on the robot. So the next, we're going to move on to the kicker circuit. The kick is made by a push type 12-volt 100 watt solenoid. While if we do some simple math here, the solenoid needs to take about 8.3 amperes of current, which is a lot of current. 100 watt is about the power consumption of your LCD monitor, and we all know that a normal battery will never get that kind of power output. So there are actually 2 solutions to solve this problem. One is using a boost circuit, which can convert your whatever your battery voltage is into a higher voltage, and use a series of capacitors to store enough energy and dispatch all the energy at once to power the kick for a short amount of time. And the other one is using our design, which uses a high-drain battery that are able to handle these high-drain discharge, well, at least for some time, a little bit of time. And to control the kicker, we uses 2 MOSFETs, which are rated at 200 volts and can pass up to max 18 amperes of electricity. The reason that we use 2 is that the threshold voltage on these MOSFETs are actually pretty high because they're designed to control high voltage and high current. So we actually have to make a 2-level switch. One switch is to control the switch of the other switch. That is simply because the 5 volt from Arduino is not enough to charge up the gate of the switch to pass through enough current. It will actually pass through about a good 0.5 amperes, but we need a whole 12 volt to charge up to fully saturate the circuit, to fully saturate the MOSFET for it to pass through about 8 to 9 amperes. And that's it for the circuit design. Thank you.